All right. Hi, everybody. Appreciate being here today. As they mentioned, my name is Tim Lundquist. So I've got a background in engineering. I've been in the industry for over 20 years. Came from Weir Minerals. Really, I guess, specialized in crushing, screening, classification technologies. I have a passion for bringing new technology to market in mining. Did that with the HPGR business with Weir Minerals. So yeah, passion for bringing new tech to the market. And at DISA, we specialize in high pressure slurry ablation, or HIPSA. And I'm looking forward to discussing that here today. So there is music with this, but I don't think it's going to come along with it. But really what this comes down to is all over the world, there's billions of tons of mine waste that sit idle in tailings dams and stacks, growing larger every single year. Oh, there it is. So yeah, we have tailings that are growing larger and larger every single year, and these aren't just environmental challenges, they're evidence of inefficiency. Each one holds valuable minerals that were never recovered. So maybe the real issue isn't that we mine too much, it's that we recover too little and leave too much waste. So within mining, there's hidden inefficiencies. There's energy waste, there's lost value, and there's growing tailings. So from a comminution perspective, it accounts for about 50% of the of mine site energy. So it's how can we work on cutting that down? Billions of tons of tailings are stored globally, and there's no real plan for addressing that. There's no real plan for how do we actually recover the lost minerals? How do we deal with that from an environmental perspective? Many operations have recoveries below 80%. As we push capacity and as mineral ore bodies become more challenging, our recoveries actually aren't necessarily increasing. So we're sending valuable minerals out to tailings that continue to grow every single year. And then decades of innovation, but really we have no fundamental change in liberation. We're really still grinding rock like it's the 1800s, we just use bigger motors. So from an actual comminution perspective and liberation perspective, we really haven't innovated all that much. That's where HIPSA really comes in. So HIPSA is very different than traditional grinding media. We use controlled slurry impacts, and it's particle-on-particle collisions. Those particle collisions create two breakage mechanisms. You're getting a breakage along natural grain boundaries, and you're getting breakage on ore hardness differences. There's really two different ways that this is happening. So on the coarser particles, we're getting comminution/size reduction. On the finer end of the profile, we're actually getting more of a scrubbing, cleaning approach. So what we don't create is a bunch of fines. What we do is liberate minerals. We're an engineering-led company. We have our entity here in Canada as well. Our core team combines over 150 years of mineral processing experience from Weir Minerals, Derrick, FMI, and Intrepid Potash. We've raised more than $53 million in private investments to date. Today we have 7 commercial units that are in operation. We are operating in 10 countries around the world, and we're growing actually very quickly, especially within the last year. We have 15 issued patents, so our technology is completely protected and we have no direct competitors. Our technology is extremely unique in that it's modular, scalable, and transformative. So if you think about like traditional technology from a ball mill perspective or even an HPGR perspective, the amount of cost to actually integrate and install these technologies is extremely expensive. The lead times are 12 to 16 months minimum. You're looking at a 3 to 6 month installation, best case. Foundations, material handling, complex circuit integration. HIPSA is a completely modular, self-contained system. So every single thing you need to operate the HIPSA unit comes as part of the skid. We can install our system within one day. All we need is feed, power, and somewhere to send the product. So up to 50% less energy consumption, 50% lower install time and cost, no media or chemicals. So one of the things that I find very interesting about mining in general and grinding media is that we've been using grinding media for, 50 years, 100 years, whatever it is, it's a long time. And so we're mining for targeted minerals, we're creating grinding media, and then we're putting it into mills and we're grinding it up to nothing, and then we're still going and mining for more and making more grinding media. It just doesn't really make any sense to me. So with HIPSA, we get away from that need for grinding media, and there's a lot of carbon that goes into just the mining of the media and then the power used to lift that media to create, very small particles. And then that's the other part of it is chemicals and coarser liberation. So the finer that you grind in mining, and you guys know this, we're going to a targeted grind size, right? A P80. So we're saying we want to get to a P80 of 45 microns, 15 microns, 150 microns, whatever it is. We're trying to get to that fine size so that the minerals are liberated. Well, when we're going to that fine size, we're creating a lot of really fine particles. And what that requires is a lot of chemicals in a lot of cases, but it also creates major downstream issues from a tailings perspective, a drainage perspective, a thickening perspective. DISA operates very different. We do not target a P80 or a grind size. We target liberation. So if we can liberate at 300 microns, that's great. But we are just targeting liberation. We're not targeting grind size. So we operate very counterintuitive to what the mining industry is used to. What we're able to achieve at coarser liberation is higher grades and recoveries. So it's a very transformative technology versus what's been done in the marketplace to date. Globally proven across commodities, as innovation goes and as new technologies go, these things change and innovate relatively quickly. I joined DISA just over a year ago, and the technology today is a lot different than it was even when I joined a year ago. We need to be flexible and grow quickly, and we need to test and trial and figure this out. So we are lab to pilot to commercial success is our strategy, but in the last year, we've had success basically on every single ore type that we've tested. We've reached that point of commercialization where we truly understand the optimal operating conditions for our equipment, and we've been able to achieve higher liberation than ball mills or tower mills or rod mills in copper, gold, phosphate, iron, pretty much across the entire spectrum. Some highlights for copper in one of the hardest copper deposits in the world, we actually achieved a 10% higher liberation. And it's one of the largest mining companies in the world. And what they were interested in is they liked the increased liberation. That was great. They enjoyed that. But what they really like about our tech is that the copper is liberated between 37 microns and 150 microns. So we're liberating in more of the sweet spot for recovery without the fines creation. Phosphate, we have a 50 ton per hour unit operating 24/7 in phosphate. That's the picture there. 15% higher recovery of phosphate versus the ball mill, and a 50% reduction in magnesium oxide. So significant impacts to their downstream process. Iron, I'm actually writing a paper around iron that'll be released for the SME in the US in, February of next year. And we're able to integrate into existing iron ore flow sheets and increase the iron grade by over 15% and reduce fines creation. So as we talk about transitioning to green steel and being able to use hydrogen-based electric arc furnaces, being able to get to that higher grade of iron is absolutely critical. And then tailings, everything in tailings, that's really what this technology was developed for, was tailings reclamation, specifically in uranium initially. And that modular nature really kind of comes into play. But if there's tailings anywhere, we can go through and we can actually liberate the minerals. So, I mean, if you think about the amount of tailings that are out there, the market there is massive. And then, yeah, we over 100 different partners. I mean, I think we've run 150 different test programs this year alone, and we're working with some of the largest companies in mining. So yeah, largest untapped market in mining. As you guys know, most operations are wet-based. They're wet slurry-based. The material is in a slurry. Pumps are very high efficiency for moving material from here to there. The grinding is done wet. So with the majority of operations being wet, our technology integrates anywhere there's a slurry. So like we have an operation, we have an installation at a gold operation in the US. We have actually tested 5 different areas in their circuit. Their recovery is below 75%. We can integrate in at all of those different places, increase liberation, and significantly increase their recovery. So you can be looking at one site, you could be looking at 10 units to bring their recovery up, especially in somewhere like gold or copper, or, whatever. You don't have to increase it all that much to make it a very attractive ROI. Our business model has really been around brownfield retrofits, so fast ROI, low risk, because our lead times are relatively low, 2 to 4 months, because our technology is relatively straightforward and simple and easy to integrate. We can go put equipment in, prove it in the circuit quickly, which will open the door to us for greenfield projects. So really right now our focus is on brownfield retrofits, and then we'll be moving into the greenfield space for actually being spec'd into future projects. Tailings reprocessing obviously adds new revenue, and there's obviously ESG benefits. Ball and tower mill replacement for greenfield, that's probably about 5 years out, maybe 3 years out. I guess it really depends, but really the focus right now is on brownfield, and then the EPCs and the clients, as they put new mines in, will be able to feel more confident putting in HIPSA. And then really HIPSA aligns with Canada's critical minerals and clean technology priorities. So we began with the tailings crisis, billions of tons of waste holding billions of dollars of trapped minerals. With HIPSA, we turn that waste into value, recovering what's been lost while reducing what's still being wasted. Our patented technology has no direct competitors, can be applied in every single wet processing circuit on Earth, including in Canada's legacy tailings and oil sands. And really, our technology, I believe, is going to be integral for growing the market demand that's needed. It's unique, it can be installed quickly, it's proven, and it's ready to go. So at DISA, this is how we liberate minerals and empower progress. So thank you. I guess I'm the first one getting grilled, so here we go.
Thank you, Tim, for the presentation. Maybe a quick question. It's proven and ready to go.
Yes.
What do you need? What do you need to take that step?
What we really need is just, material to test and people willing to, continue to put it in. I think over the last 2 months, we've shipped 6 continuous units to go to sites. I think as we continue to put units out and continue to get positive results, that will help us grow. But I think in general, it's just more people willing to test, I think is really the thing that could help. And then just, test multiple areas within the flow sheet. I think, one of the things is it's testing. There could be 4 or 5 different spots in a flow sheet to test that could bring value. Sometimes people will only test one. So it's, how do we test more within a flow sheet? And then I think, how do we integrate site success up into the corporate level? We'll get site success at some of these places, and the corporate's busy with whatever. So it's how do you elevate that up into the corporate levels? Yeah.
So I think you touched on something that I was going to ask about. So you said this year you've done roughly 150 test programs around the world, and I think you said you've got 7 units in operation. So the two-part question is how do you get your foot in the door with the miners to give it a try? And then importantly, and you touched on a little bit, how do you get that to scale, right? Because there's lots of people who like to do proof of concepts, proof of value, kind of kick the tires.
Yep.
But there's always a real challenge in kind of scaling that or even sustaining that after the proof of concept's done.
Yep.
So what advice have you got there?
Yeah, so I mean, one of the unique things about DISA that I really liked before I joined was just the modular nature of our technology and basically the ease to prove it. So our barrier to entry is a lot lower than other manufacturers because we can do lab testing, on-site pilot testing to commercial testing very easily. The burden on the mine sites is very limited because it can drop on site. It's a relatively small piece of equipment. We can go run, help train, but you're not having to. It can be a $5,000 investment to bring a unit on site and test your streams. Like if you're looking at a ball mill, an HPGR, tower mills, et cetera, like if you're looking at that larger equipment, you might be looking at a ton to a ton and a half of material to test, where we're looking at 50 to 100 kilos to get initial results. And then it's, well, crap, like we're seeing like really large recovery increases here. Let's now prove it at site and then from there be able to go to commercial. So we are a bit unique in the fact that it's a lot easier to prove it and integrate than other technologies. So that's helpful. And then we just have, our team has been in the industry a long time, so we have a lot of connections and people within the mining space. So our background and where we've been historically, we have a lot of connections with people that like new technology, which has helped us get in the door. Did that answer both of them? Okay.
Yeah, thank you, Tim. You know what? I met Grayson about maybe 4 years ago, and it's just impressive to see how far you've gone with your technology. So my question is a 3-part question.
3?
So 3-part question. Yeah. So the first question is, and I'll ask them all at the same time. They're fairly simple questions. The first one is, how many passes do you need to put the material through in order to achieve the optimum liberation? That's one question. The next question is about water conservation. Is there a facility to recirculate water? I'm just thinking about where some of the copper mines are located, where there may be water issues. Is there recirculation of water? And the third question is on energy, right?
Yep.
Does your technology use renewable energy sources in part of powering the motors that collide these slurry lines?
Right. All right, so the first question was how many passes? So it really depends on, because we can take material from 15 millimeters down, it really depends on the actual application, and it depends on the density. So in a lot of cases, we're just dropping into wherever, right? So the feed density could be 15% solids, it could be 50% solids. It could be a hard material, it could be a soft material. So it really depends, but every single one of our modular units are designed to basically be run in open circuit. So if it's 100 tons per hour in, it's 100 tons per hour out. If it's 500 tons per hour in, it's 500 tons per hour out. It's just a matter of how much volume you're pulling to recirc. So it's really more about what your installed power is going to be with, how many times you're actually going to need to recirc it to liberate it. So it could be, it could be 3 kWh per ton, or it could be, 8. So it's really just depends. And that's how we scale, is basically, okay, like how many tank turnovers do we need? We don't necessarily think about it as collisions per se. It's tank turnovers. Do we need 2? Do we need 5? And then we scale and power accordingly. But yeah, it really depends on feed density, ore hardness, difference in ore hardnesses between mineral types, and then just how much liberation is going to be needed to get your targets. The second question was Water. So I guess two things, right? So like if we're integrating in where there's already water, we're not adding water. You know, we don't have to add additional water. We just use whatever's there. I think if you're looking at it, I mean, if you look at it from, you know, if you're looking at like a magnetite iron ore operation, for example, in a lot of cases, I mean, like, for example, FMG in Iron Bridge in Australia, you know, it's a magnetite and they're taking it, it's a two-stage HPGR circuit. They're going from 80 millimeter to 80 microns. There's dry beneficiation, dry mag sep between the stages. They're removing, I think, 40% of the mass. Then they're sending it wet, you know, at less mass to the vertimills. So like in that case, instead of a vertimill, it could be a HIPSA, where you're creating less fines and using basically the same exact amount of water. So, you know, I think from our perspective, from a water perspective, it really would come down to, can you beneficiate upstream to have less, you know, material that's getting to that phase of the final size reduction? And then from a downstream tailings thickening perspective, if you're able to liberate at a coarser size, which we are, you know, just the ability to remove that water is a lot easier. And then it was developed for tailings reclamation, which is obviously dry. So like for the uranium reclamation, you know, we actually have a full water recovery circuit. So the only water that we're losing would be in the, you know, the actual like dewatering screen oversize. And then energy? Yes. So as I mentioned, like 3 to 10 kWh per ton is typically what we run. We're typically going to be significantly less than traditional technology. And a lot of that is just tied to the fact that we're liberating much more efficiently and we're liberating coarser. So we're able to basically, you know, increase grades earlier in the downstream process and then be able to simplify the downstream circuit. So even though maybe we're only 25 to 30% less on a one-to-one basis versus a ball mill, it's the downstream where we really get that increased bump.